Okay, go ahead and label the top of your paper, constant rate of change. Please keep in mind I am recording this through third period, so if you hear noise in the background, it's my noisy class. I'll just give them all punishments later. Constant rate of change is the rate at which something changes or how quickly or slowly something changes over time. We're going to start off writing that vocabulary. Okay, go ahead and copy this table. Make sure you write down your X and Y axis. This X and Y refers to the same thing like an ordered pair. So when you see X is 1, Y is -6, that is an ordered pair, 1, -6. What we will do in order to find the rate of change or how it is changing over time, we're going to compare how our X coordinates are changing on our X axis. So from 1 to 4, I add 3. From 4 to 7, I'm adding 3. From 7 to 10, I'm adding 3. And from 10 to 13, I'm adding 3. On the y-axis, from -6 to -8, what am I doing? I'm going to subtract 2. And from -8 to -10, I'm subtracting 2. -10 to -12, subtracting 2. And -12 to -14, I am subtracting 2. In order to find my rate of change, and I will write that as ROC, rate of change, I would find my delta Y over delta X. The triangle is a symbol for delta. It means change, so this will be your change in Y over your change in X. In this case, my change in Y was -2, and my change in X was +3, and it was the same all the way down. Okay, so if I were to graph this on a plane, this will be a linear function. Also, -2 over 3 will be our slope. And we'll cover slope in a little bit. Or probably tomorrow. Okay, go ahead and pause the video and write down my second table for my example number 2. As you see, my x-axis is, again, from -3 to -1, I'm increasing by 2. From -1 to 1, I'm still increasing by 2. 1 to 3 is going by 2, and 3 to 5. I don't want you to ever assume that it's going to all go the same, so go through the table and check. On the y-axis, from 10 to 12 is also increasing by 2. From 12 to 16, it's increasing by 4. From 16 to 18, it's increasing by 2. And then the 18 to 22 is increasing by 4. Okay, so if I were to make a rate of change, it's my change of y over my change in x. I have 2 over 2 for these two, for this set of ordered pair. But when I go down here, I have 4 over 2. And 2 over 2 does not equal 4 over 2. Therefore, this is not a linear function. And there is no constant rate of change. Okay, so if I were to draw this out in a line on a graph, it's not going to make a straight line. The line will eventually curve. And then the rate of change, the way that it's changing is not all the same, so the rate of change is not the same. Therefore, it is not constant. So this does not have a constant rate of change. And we do not have an exact slope.